Well, that's what we got so far with the checking of the B plus or the supply lines, and I think you can probably see that I've gone a little bit further, and I think I've gone as far as I want to go before I actually try power up minus the tubes. And one thing I've found already is that this thing would not have worked. Definitely would not have worked if I'd switched on. And the reason for that is that over here, that resistor was completely open. It's this guy over here. It's supposed to be 330K and it was reading completely open. Now, there aren't really any signs that it should be damaged, but that's what you do all these measurements for. And I've now replaced it, and I think I've got this thing to the point where I can now power it up very carefully just to check that we've got the B pluses where they're supposed to be. So let me show you inside the chassis. There's that resistor that I've swapped out, and as you can probably see, it's connected physically first to the respective solder points and then soldered on. So the solder is only used to seal the mechanical contact rather than acting as a mechanical connection in itself. First thing you might notice is that I have two resistors tacked on to the top of that output transformer, and what these are tacked across where the left and right speaker go. These are 8 ohms. It's a little bit high. I believe those speakers are probably around 5 ohms, but it won't do any damage. What it will do is probably do quite a bit of damage to the output transformers if I switch this on without any load on. Never switch on a tube amplifier or radio without a load, okay, without a speaker, without a resistor acting as a load. So these are actually doing what the resistors would do. They are 10 watts. We'll never get anywhere near that power. At least the transformers are seeing a load, and therefore the power tube will see a load if it's on. And the other one, the main speaker, I have not connected a resistor across, but I've connected this. It's wired in so that I have a socket here, and then I've got an external speaker with a plug, and I just connect it up there, and it makes it easier for me to test the radio. But that is a little bit further down the road. For now, what I want to do, I've removed all the tubes, and what I want to do is I want to power it on and see what we get. Now, to power it on, I'm not connecting it straight to the mains. I'm connecting it, I've plugged it in to this to the dimmer current limiter. What this does, it's active, so it's going to bring in those lamps in series with the load, with the radio itself, and I can switch in which loads, which lamps I want. I can have a 40-watt lamp. By switching that on, I can have a second 40-watt lamp, I can have a 60 and another 60. So I can actually put all these in parallel, but then in series with that. Now, the smaller the load here, the smaller the lamp that I use, the more restrictive it is. So if there is a short on here, it'll be like switching this on, and the lamp will glow very, very brightly. And the radio will see very little voltage. So if there's something shorted in there, it won't cause any damage. And the way we notice whether it's shorted or not is by the brightness of this globe and also the actual voltage that the load is seeing, which is indicated down here. And so I've got this. These are going to stay off. The only lamp that's on is the 40-watt lamp. It's the smallest one. And it's active, so the lamps are on. It's not bypassed. The radio selector buttons are all off, so I'm going to switch it on here, and as you can see, we've got 239 volts line voltage. It's going through that lamp, but there's no load, so this is basically an open circuit, and it's seeing the entire voltage. No current, okay? Here we go. I've got the dim lamp on 40 watts maximum restriction. It's on. I have the multimeter lead, the negative, connected to the chassis, which is ground. And now I'm going to switch on medium wave. So no tubes in there. And we've had no fireworks. The dim lamp is off, so the light actually came on just for an instant as it first came on, and then that would have been the charge or the current charging the filter capacitors and so on. And now it's invisible almost. There's 70 milliamps coming through. The voltage that the radio is seeing is actually 219, so there's about a 20 volt drop across the lamp. So now I'm going to test the anodes of the ELL80, and that should be 3 and 7 we're expecting, which should be about 257 volts. It'll be higher. Let's just check. 3. Yep, it's higher, 304 volts, and that's normal because there's no current draw really, which would drop the voltage. So 3 and 8. Yep, 3 and 8. Right, same voltage, great. Now we can check the screen grids, which is 1 and 9. That should be just slightly lower. And that one's there, and that one is there. Great. Now I'm going to check the same on the ECC83, which is the preamp tube, and that should be 1 and 6. So 1, yep, lower voltage obviously. 2, 3, 4, 5, and 6. And it's there as well. Brilliant. Okay, so we've got power coming to the tubes. The voltage is a bit high as expected, but that's normal. Oh, one other thing I do want to check is I want to check the grid voltages on the tubes. Now the grid voltages on both the preamp tube, the ECC83, and on the power tube, all the grids should be 0 or damn close to 0. And the reason for that is that there's a resistor to ground which grounds it, and the signal coming in comes through a DC blocking capacitor. It's on all the preamp and power amp tubes, you'll get a DC blocking capacitor. So we should get 0 volts, and if we don't get 0 volts, it means that the DC blocking capacitor, which comes from high voltage in the previous section, usually the anode circuit, it means that those DC blocking capacitors are leaking DC voltage and leaking current, which creates a positive DC voltage on the grids. And if it does that, then the tubes can run away with themselves, because they should never be positively biased. So you basically need that capacitor to keep that DC away from the grids, just past the AC signal, the audio signal. And if you do get DC coming through, it messes up your bias, and it can really make your tube overheat because of excessive current draw. Now, if we look at the ECC83, that's pin 2 and 7, I believe it is. So let's see, 1, 2, damn near 0 volts, yeah, and 7, yeah, that's okay. And on the ECC ELL80, that will be pin 2 and pin 6. So 1, 2, yeah, that's pretty good. 0, 3, 4, 5, and pin, whoa, 127 volts. Am I on the right pin? 6, yeah, I am. 127 volts. Damn, let me switch that off. That means that that capacitor is leaking like bloody crazy. That capacitor is actually more like a low value resistor than a capacitor at all. So good thing this is something that was checked, because it means that before putting anything onto that tube, before putting that tube in and putting power to it, you've got to solve those blocking capacitor problems. This is something that I try to remember to do every time before switching on a set. I think I've never had such a leaky capacitor before. Not to that extent. I mean, I've had a few positive volts, a few volts, never that much. On the previous stage, that signal comes from the Where does it come from? It comes from the anode of the ECC83. So what it's doing is it's actually taking the anode voltage. Here we go. Comes from the anode circuit, yeah. It's taking the anode voltage and passing most of it through. So that's the first thing to change over. Now, okay, I've switched it off because that is dramatically high. Very, very high. What I'm going to do now is I'm going to check the B pluses on the other tubes, and then I'm going to get stuck in and change those two capacitors, that capacitor, probably change both before I even test this. Obviously these are the capacitors, amongst the capacitors that will be changed anyway, but before doing any further testing, I think I'll just swap those out first, make sure that I don't forget and have some kind of blowout here. Those are the two offending capacitors. I swapped them both out already since I was in the vicinity. Those two are the coupling caps, or the DC blocking caps, going into the grids of the ECL80. So ELL80. So I think what I'm going to do now is flip this around, put in the power amp and the preamp tubes, and see what we get. Ready for testing the audio stage. So I have the signal generator pumping a 500 hertz signal in there. It's 200 millivolts RMS into one of the channels of the TA input, so the pickup input. And I have the pickup selected here. And listen to this. Brilliant. Brilliant. It works. So we have the power amp, at least one channel of the power amp's working. Let's try the other one. Remember, this is stereo input. It's in the other one, and it too works. The volume is slightly lower here, so there must still be something wrong. Maybe it's the balance control, which I've noticed is completely jammed up. Okay, this is the balance control back here, and it's jammed, so it could be that, but we'll check. At least we know that the power amp, preamp and power amp stage is showing signs of life. And what I'm doing now is I'm taking the signal, the audio is coming from the middle transformer, so that it's the main speaker transformer, whereas the other two, the left and right channel for higher frequencies, are terminated with an 8 ohm load. So we're not actually listening to the entire complement of speakers, just the one, but that's fine. That's what I wanted to know. And you know what? My curiosity is buzzing like crazy. I started wondering if there was any risk of actually putting the tubes in, the other tubes in, and see if we get any reception. And I actually have spares for all the other tubes, so if one goes, hey, tough. And I really want to see this thing work, so I'm going to switch it off, put in the tubes, and we'll see what we've got. Okay, this is it. I've got external antennas both on the FM and on the AM. I have my speaker connected through that jack over there to the middle transformer, so same as with the pickup test that we did a little while ago. I've got everything off at the moment. Put that guy on. And now I think I'll start with medium wave. Let's have a look. The light came on and it's dimming, so that's a good sign. Now we've got to listen to the speaker and see if we hear anything. Give it some time to warm up. Well, so far I get no sound. The current draw is at 100 milliamps. Should hear something by now. try shortwave. Nothing. FM. Oh, I can hear a bit of a rustle. Volume's on max. I'm going to give it one more lamp, so I'm going to reduce the limit a little bit more. Oh yeah, dude. And it's FM. I've got FM, which is, oh, brilliant stuff. Sounds like crap because it's coming out of the one speaker only. Brilliant.
Muy buenas tardes. Bueno, ¿qué es exactamente esa red educativa sin fronteras? Aunque
there's my graphic equalizer at work.
Pero en general, ¿qué es este proyecto? Bueno, esta red educativa sin frontera ahora es una familia desde 14 años. Nació en 2004 y porque yo vivo en un país donde hay mucha cooperación, mucha ONG, pero se ha ocurrido que cada vez más hay más pobreza y más jóvenes que quieren salir del país. Entonces, ¿en qué sirve este dinero de la cooperación en ese país?
Now, I wonder why these guys don't work.
Que, por ejemplo, si hablamos...
I wonder if it's the antenna. Oh, this thing hasn't got a ferrite antenna. That's right, this thing is completely open. The ferrite antenna terminals are those two over there, and there's no antenna at all. So maybe, I wonder. Oh, I can hear something. Let's try long wave. Oh, and the other thing that I forgot. This thing won't tune at all either because the dial cord is gone. So let me try something. Let me put this on here. It's crackling a bit. I was worried about that. Okay, I'm touching it and I'm getting something there. Let's see if I can tune this manually, and you've got to be careful because there's high voltages around here. It seems to be tuning. We try medium wave again. I wonder if this has got anything to do with it. What was it? Oh, I was touching ground. Okay. Oh, I know what I can do. I've got that little... I've got this guy over here. I'm going to connect it with crocodile clips. I don't know which way around or anything, but there's two solder points here, two connectors. I'm going to connect it to those points over there. Let's see if we get anything. Now the crocodile clip. Now this thing will be a miracle if it works. Yeah, would have been a miracle, wouldn't it? Oh, wait a minute. It's trying to tune. Long wave. Let's try long wave. It's definitely tuning. Ah! And you know, this is a miracle because I never get anything on long wave, and this miracle is a result of a little experiment I did with a mini whip antenna, which I'll probably speak about in the future video, which works really great. So that works. Great stuff. Medium wave again. Let's see. I'm sure this, you should be able to deactivate it, the ferrite antenna thing. I can hear something, but it's not tuning. Try medium wave. No, not much there. FM is there, and that's the main thing. And that, hearing that, is like taking a Red Bull to the restoration efforts. Re-energized, refocused, motivated. It really gives you a bit of positive drive, because now you know you're working towards fixing or repairing, finalizing a radio that works partially at least, and I'm sure we'll get this thing going and it'll be great. That FM actually sounds pretty good, even the way it is. It sounds pretty powerful, and I know how I'm supposed to get stations where I am here. It's not that great. I'm pleased. I'm really pleased. So I'm going to move on and start doing recapping and report back periodically with anything that might sound interesting or catastrophic. Who knows?